Welcome to the GED Math from the absolute beginning. In this video, we are looking at the first 5 chapters from the basic math section of the Ultimate GED Math course. There are 33 chapters in the course. This course will not just make you pass the GED Math. It will solve your math problems forever. After watching this, go to ultimateged.com and get the rest of the course. You're not just getting 28 extra chapters. You're also getting quizzes, a private social group, access to us, and all future update. You can pass the GED Math with ease. Let's start from the absolute beginning. We are starting with Introduction to Numbers. Question 1. The number 2 is. Here we are supposed to select all that applies. To get this right, we need to know the kind of numbers. Counting or natural numbers are the numbers we count, so we have 1, 2, 3, 4, and so on. When you add 0 to these numbers, we have whole numbers. So whole numbers are 0, 1, 2, 3, 4, and so on. When we add negatives, we have integers. We have 0, 1, 2, 3, and so on, and we can add -1, -2, -3, and so on to get our integers. When you add fractions to integers, then you have rational numbers. So we have -2, -3 over 2, -1, 0, 1 over 2, 1, 5 over 4, 2, and so on are rational numbers. We'll take a deeper dive into rational numbers with the next question. Let's just use this information for now. Okay, so looking at this, you'll notice that once a number is in a lower level, it means it's in all the levels above it. If a number is here, then it will automatically be here and here. For our question, we can say that 2 is a counting or natural number, check. 2 is a whole number, check. 2 is an integer, check. And 2 is a rational number, check. So we have our answer. Let's try -5. See if you can do it yourself. -5 is not a natural number because natural numbers are 1, 2, 3, and so on. -5 is not a whole number because whole numbers are 0, 1, 2, 3, and so on. -5 is an integer. We know that negative counting numbers are integers, and -5 is a rational number. Let's try a more trick question. If x is a positive integer, then x is also. Please try this. Let's look at question 2. How many elements of the set 0, -1, pi, -4/7, √2 are rational numbers? A rational number is the ratio of two integers. We know our integers are positive counting numbers, 1, 2, 3, and so on, and negative counting numbers, -1, -2, -3, and so on, and 0. So if we take any of the numbers over another number, we have a rational number. So -2 over 3 is rational, 5 over 7 is also rational, so 4 over 1 is also rational. Note that any number over 1 is the same number. So 4 over 1 can simply be written as 4. Please note that for a rational number, the denominator or number at the bottom cannot be 0, although we said you can pick any two integers. So example, 8 over 0 is not a rational number. It is undefined. Please note this as the exception. But the top or numerator can be 0. So 0 over 8 is a rational number. Moving on, irrational basically means not rational. You cannot write it as a ratio of two integers. The most common irrational numbers you'll find on the GED are pi, √2, and √3. Let's look at our question now. So 0 is a rational number. We know we can write 0 as 0 over 8, or 0 over 1, or 0 over 1000. 0 over any number is 0. -1 is also a rational number. We can write it as -1 over 1. Pi is an irrational number, as we just learned here. We will explain that more in later lessons, but please take note of it. -4/7 is a rational number. It is an integer -4 over another integer 7. √2 is an irrational number. Please don't assume all roots are irrational numbers. Example, √9 is a rational number because the square root of 9 is 3. So we can say that 3 of the elements are rational. When dealing with fractions or integers, it's easy to tell that a number is rational, but when dealing with decimals, it becomes quite confusing if you don't know what you're looking for. In this question, we are supposed to find the number that is irrational. For decimals, we look at an irrational number as a number that has non-repeating and non-terminating decimal. Therefore, for a rational number, the decimals must either repeat, like 0.222 repeating. We use this dots to show that the numbers continue. Here, the 2 repeats, or the decimals must terminate. Example, 7.35. There are no more numbers after the 3-5. No dots to show that it continues. So for multiple choice A, we can see that the 3 is repeating, so it is a rational number. This decimal is actually the same as 1/3. You can check it out on your calculator. 1 divided by 3. For choice B, we can see that we have 27, 27, 27. The 27 is repeating, so it is a rational number. Same here. This has 1, 2, 3, 1, 2, 3, and 1, 2, 3. The 1, 2, 3 is repeating, so it's a rational number. For the last one, when we look at the decimals, we have 0.4142136 and so on. The numbers are not repeating in any orderly form, so we say it's non-repeating. Also, the number continues, so we say it's non-terminating. We can therefore say that the 1.4142136 and so on is an irrational number. This is actually the same as √2, which we already know from the previous question to be irrational. Try it on your calculator. Square root of 2. So this is our answer. Please note that the calculator will give you to a certain number of decimal places. So some calculators will show 0.333, others will show 0.333333, and others will show something different based on the number of decimal places. The dots are not shown. Please note also that usually, unless you are being tested on your ability to know rational and irrational numbers, most GED questions write all irrational numbers in an approximated form, making it look like a rational number. Example, although pi is an irrational number, 3.1415926 and so on the GEDs you are told to use 3.14, making it look like a rational number, although it is actually irrational. Question 3. John sold $345 worth of goods on Monday, $843 worth of goods on Wednesday, and $1,524 of goods on Friday. How much money did he receive on those 3 days? Do not use a calculator. You are usually not allowed to use a calculator on GED math questions involving operations on whole numbers. This question is asking for the total amount of money. You will therefore have to add the 3 amounts. The work involved in adding whole numbers is to align the numbers from the unit column or the right. Add them starting from the unit column and carry values to the next column if you have 2 digits values. So here we have 345, then 843, and then 1,524. Please make sure they are aligned starting from the unit column, that's the right. It cannot look like any of these. All 3 numbers must align at the right. Let's add, starting from the right. 5 plus 3 plus 4 is 12. Because it's a 2-digit number, we will put the 2 here and carry the 1 to the next column. We move to the next column. We have 1 plus 4 plus 4 plus 2. This is 11. Again, this is a 2-digit number. We will keep the 1 and carry 1 to the next column. We move to the next column. We have 1 plus 3 plus 8 plus 5. This is 17. We have a 2-digit number. We will keep the 7 and carry the 1 to the next column. Finally, we have 1 plus 1 here. This is 2. So our final answer is $2,712. Question 4. A businesswoman made $34,937 in sales. She then pays $3,556 in taxes on that money. How much money is left? Do not use a calculator. This is a typical subtraction question. Here, you are supposed to subtract the $3,556 from $34,937. Like we did in addition, you'll have to align the values from the unit column. That's aligning from the right. So we have 34,937 minus 3,556. We start from the units column. 7 minus 6 is 1. We move to the next column. We have 3 minus 5. Since 3 is less than 5, we will have to borrow 1 from the next column. This is 9. When we borrow 1, it now becomes 8. When you borrow, the value is 10, so we will add 10 plus 3 to get 13. For simplicity's sake, we will say that when you borrow, you'll just put 1 in front of your number. So we have 13 minus 5, which is 8. Next, we know we have 8 here now. 8 minus 5 is 3. We move to the next column. 4 minus 3 is 1. Finally, we have 3 here. Nothing to subtract from, so we have 3 minus 0, which is 3. So the amount of money left is $31,381. There are a lot more to exponents than what we will cover in this video. This is because we will cover exponents again when we look at exponents in algebra. Before we even look at our question, I want us to solve this problem permanently. Exponents shows the number of times a number multiplies itself. 2 exponent 3 is not the same as 2 times 3. 2 exponent 3 means 2 multiplying itself 3 times. That is 2 times 2 times 2. This is 2 times 2, which is 4. Then 4 times 2, which is 8. This is not the same as 2 times 3, which is simply 6. 5 exponent 4 is 5 times 5 times 5 times 5. This is 625. It is not 5 times 4, which is simply 20. I cannot count the number of times I've seen students get this part wrong. Please take note of it if you're not already familiar with it. Now that I've gotten this out of the way, let's look at our question. Question 5. We are supposed to calculate 3 exponent 10 times 3 exponent 5 all over 3 exponent 12 without using a calculator. If you have two numbers multiplying and the bases are the same, you can just add the exponents. Example, let's look at 2 exponent 3 times 2 exponent 4. Because they both have the same bases, which is 2 in this case, we can just add the exponents. So this will be 2 exponent 3 plus 4, which is 2 exponent 7. Now, if you have a number being divided by another number with the same base, then you can simply subtract the exponents. So 2 exponent 5 divided by 2 exponent 2 will be 2 exponent 5 minus 2, which is 2 exponent 3. Please, these two rules applies only when the bases are the same. It will not work for 3 exponent 5 times 2 exponent 4. The bases are different. One is 3 and the other is 2. Even if the exponents are the same and the bases are different, it won't work. Example, 3 exponent 5 times 2 exponent 5. The exponents being the same is irrelevant. The bases are not the same, so we can't use this. So for our question, we can see that they all have the base of 3, so the rules can apply. So 3 exponent 10 is multiplying 3 exponent 5, so we can add the exponents to get 3 exponent 10 plus 5. This will give us 3 exponent 15. This 3 exponent 15 is being divided by 3 exponent 12. We know that when terms with the same base divide, we can simply subtract their exponent. So we have 3 exponent 15 minus 12, which is 3 exponent 3. So this is the answer. They could have required you to further simplify the 3 exponent 3, which will be 3 times 3 times 3. This will be 27. The concept of exponent 1. Any number exponent 1 is that same number. Example, 5 exponent 1 is 5. That's all you need to remember if you don't care about why. We said exponents represents the number of times a number repeats itself. So if we say 2 exponent 1, then it means 2 repeats just once, which will simply be 2. So 76 exponent 1 is 76. The concept of exponent 0. Any number exponent 0 is 1. Example, 5 exponent 0 is 1. That's all you need to remember if you don't care about why. Let's look at 2 exponent 3 divided by 2 exponent 3. In mathematics, any number divided by itself is 1. So 2 divided by 2 is 1. 100 divided by 100 is 1. Basically, if the numerator and denominator of a fraction are the same, then the value is 1. The numerator is the top value and the denominator is the bottom value. So we know the value of this is 1, since the numerator and denominator are the same. But in exponents, we learned that when two things divide, provided the base is the same, you can subtract the exponent. We learned this from the previous question. So this can be written as 2 exponent 3 minus 3. 3 minus 3 is 0. So this is 2 exponent 0. 2 exponent 3 over 2 exponent 3 is 1. And 2 exponent 3 over 2 exponent 3 is also 2 exponent 0. So we can say therefore that 2 exponent 0 must be equal to 1. We can take any number and exponent, provided the numerator and denominator are the same, we will end up with the same thing. Here, we chose 5 exponent 4 and we ended up with 5 exponent 0 equals 1. Here, we chose 7 exponent 2 and we ended up with 7 exponent 0 equals 1. Question 6. Calculate 2 exponent negative 3 times 16. Do not use a calculator. Let's look at 2 ways to solve it. Method 1. I don't really expect most people at this stage in the GED course to use this method, but I want to throw it out there because it's easy and straightforward. Method 2 is what most of you will be familiar with. This first method just requires that you know that 16 can be written as 2 exponent 4. Try it on your calculator. Once you know that, then you can replace the 16 with 2 exponent 4. We have 2 exponent negative 3 times 2 exponent 4. We learned earlier that if you have two numbers multiplying and the bases are the same, you can just add the exponent. So here we will have 2 exponent negative 3 plus 4. We haven't done negative yet, but negative 3 plus 4 is the same as 4 minus 3, which is 1. So we have 2 exponent 1. We know that any number exponent 1 is the same number, so 2 exponent 1 is simply 2. This is our answer. Method 2. First, we have to know that we can move a number with an exponent from the numerator to the denominator, or denominator to numerator, by changing the sign of the exponent. Example, if you have 2 times 7 exponent negative 4 over 3, we can move the 7 exponent negative 4 from the numerator to the denominator. If we do that, we have to change the exponent negative 4 to exponent positive 4. So we have 2 over 3 times 7 exponent positive 4. The 7 exponent negative 4 in the numerator became 7 exponent positive 4 in the denominator. Notice that there's this 2 in the numerator and 3 in the denominator. If you are not given any values in either one or both, you can use one. This is not a necessary step, but can serve as a guide. Let's go to our question. We have 2 exponent negative 3 times 16. Here, we do not have a denominator, so we can use 1. So we'll have 2 exponent negative 3 times 16 over 1. We know we can move the 2 exponent negative 3 to the denominator to become 2 exponent 3. Notice that the exponent negative 3 became exponent positive 3. 1 times 2 exponent 3 is simply 2 exponent 3. So we have 16 over 2 exponent 3. 2 exponent 3 is 2 times 2 times 2, which is 8. We have 16 divided by 8. This will give us 2 as our final answer. Welcome to another video from our Ultimate GED Math course. In this video, we will be looking at multiplication of whole numbers. This lesson will be from our pre-algebra course. It covers the topic very well, so we decided to use it here. Please watch the full video, especially multiplying with 2 digits and more, and also how to deal with zeros. Okay, let's dive in.
Multiplication of whole numbers. Let's go straight ahead and use an example to explain this. We want to multiply 235 by 4. We want to line them up from the units column as usual. Then we multiply each digit in the 235 by the 4, starting from the units column. So we multiply 5 by 4 to get 20. This is a 2-digit number, so we write the 0 and carry the 2, as we learned when we were adding. Next, we multiply the 3 by the 4 to get 12, and add the 2 we carried. This gives us 14. Again, this is 2 digits, so we write the 4 and carry the 1. Multiply the 2 by 4 to get 8. Don't forget to add this 1. This gives us 9. The highest mistake students make here is forgetting to add the numbers they carried after multiplication, so please avoid that problem. Let's take another example. Multiply 54 by 8. Let's first line them up. Now we multiply each digit in the 54 by the 8. 4 times 8 is 32. Since this is double digit, we will keep the 2 and carry the 3. Next, we multiply 5 by 8. This gives us 40. We add the 3 we carried to get 43. Since there is no number to carry the 4 to, we just write it. Multiplying with double digits. Let's use an example to explain this. We want to multiply 753 by 62. Here again, we align them. We work with the 2 here first. We multiply each digit in the 753 by the 2. So 3 by 2 is 6. Then we do the 5 by 2 to get 10. This is a double digit, so we will keep the 0 and carry the 1. We now multiply the 7 by 2 to get 14. Add the 1 we carried, and we have 15. Let me wipe this 1 out so we do not get confused with our next steps. Next, we work on the 6. We multiply each digit in the 753 by 6. We do 3 by 6 to get 18. This is a double digit, so we have to keep the 8 and carry the 1. Now, since this 6 is in the tens place, we place its value from here, under the 6. We write the 8 down. We then multiply the 5 by 6 to get 30. Don't forget to add the 1. We have a double digit, so we keep the 1 and carry the 3. Next, we multiply the 7 by the 6 to get 42. We add our 3 to get 45. Now the next step will be to add vertically. Since we just have 6 here, we bring it down. Next, we add the 0 and the 8 to get 8. We then add the 5 and 1 to get 6. Finally, since we just have 4 here, we just bring it down. So this will be our final answer. Notice that if you are multiplying a 3-digit number, the idea will be the same. It will look like this. The first digit multiplies and is placed starting from the unit place. The second digit multiplies and is placed starting from the tens place, and the third digit multiplies and is placed from the hundreds place. You will then add the numbers from the unit column as usual to get this as your final answer. Multiplying with 0. When multiplying by a number with zeros behind, like 20, it is not necessary to go through the normal multiplication method. Example: the normal way we will go about multiplying 34 by 20 is this. We first multiply by the 0. We know that any number by 0 is 0. So 4 times 0 is 0. 3 times 0 is 0. Then we move to the 2. 2 times 4 is 8. Then 2 times 3 is 6. We add them to get 680. A simpler way when the 0 comes after the number, like 2300 or 20 or 500, will be to ignore the zeros when multiplying and bring them to your final answer after you are done. Example, let's multiply 72 by 300. Here we say we can ignore these two zeros. So we work on 72 times 3. This will give us 216. Then after this, we just bring our two zeros after it. This will be our final answer. Please note that this does not work for zeros within digits like 2, 0, 5, or 1, 4, 0, 2. The zeros must be at the end. Let's end this video here. It is important to go through this as many times as needed to familiarize yourself with the steps of multiplying and adding after multiplying.
We will be looking at division of whole numbers. This lesson will be from our pre-algebra course. It covers the topic very well, so we decided to use it here. Please watch the full video, especially how to cancel zeros and using remainders. This knowledge will help when we work with mixed numbers and improper fractions. Okay, let's dive in.
Let's take an example to explain this. If you are given 9 divided by 4, we can write it in the long division form. The number here is our dividend. The 4 here is our divisor. To solve this, let's bring our 4 multiplication here. We want to find the number that is closest to 9, but not greater than 9. Here we will see that 8 will be the closest to 9. We put the 8 here. Then we find the number that multiplied the 4 to get 8. We see that the number is 2. So we put the 2 as the quotient. The final step is to subtract the 8 from the 9 to get the remainder of 1. So we can write our final answer as 2 remainder 1. Let's take another simple example. We want to divide 18 by 3. We write it in the long division method. Let's bring our multiplication table again. Remember, we are looking for the number closest to 18, but not greater. Here we notice that the closest number to 18 is 18 itself. So we write our 18 here. We know that 3 multiplied 6 to get the 18, so we write 6 as our quotient. Next, we will subtract. We notice that this will give us 0, meaning we have no remainder. So this is our final answer. Dividing larger numbers. Let's now look at a number that is larger. We want to divide 253 by 2. When you have a larger number, it is encouraged to work on one digit at a time. So we start with the 2. Let's bring our multiplication table. Same idea. We look for a number that is close to 2, but not greater. Here we see that the number is 2. We write our 2 here and the 1 here. We subtract and get 0. The next step in this method is to drop down the next digit and work on it. Again, same idea. We notice that the closest number to 5 is 4. We put the 4 here and the 2 here. Our next step, as usual, is to subtract. We have 5 minus 4 to get 1. Next, we drop the 3. So now we have 13 to work with. We know the closest number is 12. So we have our 12 here and our 6 here. We will subtract and have our remainder of 1. So our final answer is 126, remainder 1. Please note that the multiplication table will not be provided. That is why you have to memorize it. Let's take another example. 452 divided by 6. We work on a digit at a time, so we start with the 4. Since 4 is smaller than our divisor 6, we cannot divide it, so we will work with the 45. Let's bring our 6 multiplication table. We can see that the closest to the 45 is 42. We put our 42 here, and the 7 becomes our quotient. We then subtract 45 minus 42 to get 3. We drop the next number, which is 2, giving us 32 to work with. The closest number to 32 is 30 from the table. So we have our 30 here and the 5 up here. We can now subtract the 30 from 32 to get a remainder of 2. So our final answer is 75, remainder 2. Let's end this video here. It is very important that you go through lots of examples. Please go through all the examples and master this today.
Question 9. The absolute value of -8 is less than, greater than, or equal to the absolute value of 8. Compare the two values. When you see these lines with a number, we are dealing with the absolute value. Let's bring our number line to explain absolute values. This is a number line with integers. Starting from 0, when we move 2 to the right, we say we've moved +2. When we move 2 to the left, we say we've moved -2. Absolute value doesn't care about whether the movement was to the right or to the left. It just cares about the fact that you moved 2. Whether you move to the right, which is +2, the absolute value is 2. Or you move to the left, which is -2, the absolute value is 2. So for our question, we can say that the absolute value of -8 is 8, and the absolute value of +8 is also 8. So these values are equal. Question 10. Arrange -2, absolute value of -5, absolute value of 7, -4, and negative absolute value of 9 in ascending order. Here, we are supposed to arrange the values from smallest to biggest. Let's start by simplifying all the absolute values. We know that the absolute value of -5 is simply 5. We also know that the absolute value of 7 is simply 7. For the negative absolute value of 9, it's a trick. You'll notice that, so far, the negatives have been within the absolute value marks, but this has the negative outside the absolute value marks. So we are not finding the absolute value of -9, like we did for absolute value of -5. We find the absolute value of 9, which is 9, and then bring the negative. So we have -9. Now let's arrange them. -9 is the smallest, so we have negative absolute value of 9. Then -4, then -2, then 5, which is absolute value of -5, then absolute value of 7. We will end this video here. Have a great day. See you in the next video. Question 11. -5 minus 4 equals. To solve questions like this, all you need to remember is that if two numbers have the same signs, you'll add and keep the sign. And if two numbers have different signs, you'll subtract and keep the sign of the larger number. So for this question, the 5 is negative. Please note that the middle sign is considered the sign of the number after it. So the sign of this is also negative. So they have the same signs. We said if they have the same signs, you'll add them and keep the sign. So we 5 plus 4, which is 9. And we bring the sign negative to get -9 as our answer. So if we had -5 plus 4, we will have one of the numbers to be negative and the other to be positive. If the signs are different, we will subtract and keep the sign of the bigger number. So we have 5 minus 4 to get 1. Since the larger number, 5, is negative, we will keep the negative. So we have -1 as the answer. Question 12. -3 minus -5 equals. How to solve this is just like what we did in the previous question. The only thing different is that there are two signs in the middle. When you have minus negative, it is the same as plus. So this is the same as -3 plus 5. We have one of the values as negative and the other is positive. We said if they have different signs, you'll subtract and keep the sign of the bigger number. So we subtract 5 minus 3 to get 2. Since the positive 5 is the bigger number, our answer will be positive 2, which is simply 2. Note that if you had plus negative, you can simply change it to minus. So that 3 plus -5 is simply 3 minus 5. Changing two signs in the middle to a single sign is not a necessary step if you know what you are doing. I personally don't use it, but I've seen that it's very useful to students who are new to this. Please take note of this because some students were confused when we used this idea in our video on simultaneous equations. Question 13. -4 times -3 equals. The multiplication of negative integers is the same as the multiplication of whole numbers. The only thing you have to remember is that when two numbers multiply and they have the same signs, the final answer is positive. If they have different signs, then the final answer is negative. Please don't confuse this with the rules of addition and subtraction. So, -2 times -9 will be positive 18 because they are both negative. -2 times 9 will be -18 because one is positive and the other is negative. Let's look at our question. So this will be positive 12 as our answer because both values are negative. This idea is the same for division. So 27 divided by -3 will be -9 because one of the values is negative and the other is positive. Question 14. -2 exponent 2 equals. We were actually surprised at the number of students that were confused about our statement in our GED Math 2021 video that -2 exponent 2 is not the same as -2 exponent 2. We said in our previous video that exponent represent the number of times a number multiplies itself. In this question, the exponent is affecting only the 2. So we will have 2 times 2, and then we have the negative in front. 2 times 2 is 4. So we will have -4 as our final answer. If we are given -2 exponent 2, with the -2 in parenthesis, this means that the exponent is affecting the negative and the 2. So we will have -2 times -2. We learned earlier that when you multiply two negative integers, you'll get a positive answer. This is positive 4. So the difference is that one gives a negative answer and the other gives a positive answer. Before we look at our questions, let's quickly run through the order of operations. In math, the order of operations are parentheses. You'll perform any operation in parentheses first. Exponents. This includes roots, which we will learn in later lessons. Multiplication and division from left to right. This means that if you have, let's say, 4 times 3 divided by 2, you'll do the multiplication first and division second. But if you have 4 divided by 3 times 2, you'll do the division first and the multiplication second. I know a lot of students are stuck on PEMDAS, so they assume multiplication operations are always done before division operation, but that's not the case. Multiplication and division are on the same level. You work it out from left to right. Then finally, addition and subtraction also from left to right. It's also on the same level. Let's take our questions. Question 15. We are supposed to calculate this without using a calculator. 4 parenthesis 7 minus 2 divided by 2 equals. In math, if you see a number attached to another value in parenthesis, it means it's multiplying. So 2 parenthesis 4 is the same as 2 times 4. Let's bring the order of operation. Looking at this question, we will perform the operation in parenthesis first. So we have 7 minus 2, which is 5. Now we have 4 times 5 divided by 2. Since there's no exponent, we can work on the multiplication and division. Remember, we have to do it from left to right. So we have 4 times 5, which is 20. Then divided by 2. 20 divided by 2 is 10. So this is our answer. Mastering the order of operations just requires practice. Let's look at more questions. Question 16. We are supposed to calculate this without using a calculator. Parenthesis 2 plus 5 squared plus parenthesis 3 plus 7 times 2 equals. You can pause and try it. Let's bring the order of operations. Here, we have 2 parentheses. We have to do both of them first, or you can also do one first and the other next. I'll work on them both. For this one, we have 2 plus 5, which is 7. We have 7 exponent 2, plus, we do 3 plus 7 to get 10, then times 2. From the order of operations, we have to do the exponent next. So we have 7 squared, which is 49. We have 49 plus 10 times 2. Next, we have to do the multiplication or division. We have multiplication, so we will do 10 times 2 to get 20. We have 49 plus 20. Finally, we do the addition operation, 49 plus 20 to get 69 as our final answer. Question 17. We are supposed to calculate this without using a calculator. Let's bring our order of operations. Again, we will perform the operations within the parenthesis first. We notice that there's parenthesis within parenthesis. In this case, we will perform the inner one first. So we have 3 plus 2 to get 5. We now have parenthesis 28 minus 5 times 5, all squared, minus 5. Using the order of operations, we have to perform the operation in parenthesis. We'll notice that the operation in parenthesis also has multiple operations. That's subtraction and multiplication. We will use the order of operation to work that out. We know we have to do multiplication before subtraction. So we have 5 times 5, which is 25. Then we have 28 minus 25, which is 3. Now all these has been simplified to 3. We now have 3 exponent 2 minus 5. From the order of operations, we will do the exponent next. 3 exponent 2 is 9. We have 9 minus 5. Finally, we'll do the subtraction. 9 minus 5 is 4, so we have 4 as our final answer. Question 18. We are supposed to calculate this without using a calculator. 30 over 2, in parenthesis 3 plus 5 minus 6 equals. I want you to try this. We haven't exactly done this. In order to get this right, you have to apply what I call implied parenthesis. Let me give you a clue on how to solve it. When you have an operation or multiple operations in the numerator or denominator, you'll have to work on it like it actually has parenthesis, although it is not written. So if you have 3 times 8 over 2 plus 1 plus 5, this will be worked out as if it has parenthesis. So from the order of operation, we do parenthesis first. We have 3 times 8, which is 24. Again, we work on this parenthesis 2 plus 1 plus 5, which is 8. We now have 24 divided by 8, which is simply 3. So for this question, you'll put a parenthesis here. This should help you solve this question. Question 19. Which of the following are factors of 24 and also a multiple of 2? Here, you are supposed to select all that applies without using a calculator. To answer this, you have to know what factors are and also what multiples are. The factors of a number is any number that can divide that number without a remainder. For a question like this, it's important you work from the answer. Can 4 divide 24 without a remainder? The answer is yes. 24 divided by 4 is 6, so 4 is a factor. Can 10 divide 24 without a remainder? The answer is no. 24 divided by 10 is 2.4, or simply 2 remainder 4. So 10 is not a factor. Can 3 divide 24 without a remainder? The answer is yes. 24 divided by 3 is 8. So 3 is a factor. Can 12 divide 24 without a remainder? The answer is yes. 24 divided by 12 is 2. So 12 is a factor. The question says that the value must also be a multiple of 2. Multiples are basically the results when you multiply a number. The number cannot be a fraction or decimal. The multiples of 2 are 2, 4, 6, 8, 10, and so on. You can see that this is basically the multiplication table. No need to go through all the numbers. We are just going to go through the numbers that are already factors. We said 4 is a factor of 24. Is 4 also a multiple of 2? The answer is yes. 2 times 2 is 4. We said that 3 is a factor of 24. Is 3 also a multiple of 2? The answer is no. 2 times nothing will give 3. So although this is a factor of 24, it is not a multiple of 2. Finally, we said 12 is a factor of 24. Is 12 also a multiple of 2? The answer is yes. 2 times 6 is 12. So our answer is 4 and 12. 4 and 12 are factors of 24 and also multiples of 2. Question 20. Find the greatest common factor, GCF, of 18 and 24. Greatest common factor is the same as highest common factor. We are going to use 3 methods. Method 1. We can find the factors of 18. That will be 1, 2, 3, 6, 9, and 18. These are all the numbers that can divide 18 without a remainder. Then we will find the factors of 24. That will be 1, 2, 3, 4, 6, 8, 12, 24. The greatest common factor will be the largest number that is common to both 18 and 24. This will be 6. Method 2. For this method, we will use prime factorization. A prime number is a number greater than 1 with only 2 factors, themselves and 1. Examples. The factors of 2 are 1 and 2 itself, so 2 is a prime number. The factors of 3 are 1 and 3 itself, so 3 is a prime number. The factors of 4 are 1, 2, and 4. Since this has more than 2 factors, it is not a prime number. Other prime numbers are 5, 7, 11, 13, 17, and so on. For our question, we want to break each number to its prime factors. We start with 18. 18 can be divided into 2 times 9. Since 9 is not a prime number, we will further expand it. 9 can be broken into 3 times 3. Now all the values are prime numbers, so there's nothing further we can do. So the prime factors of 18 are 2 times 3 times 3. Please note that it doesn't matter what prime number you start with, provided it can divide the number, you'll have the same results. Next we find the prime factors of 24. 24 can be expanded as 2 times 12. 12 is not a prime number, so we break it down further. 12 is 2 times 6. We break the 6 down to get 2 times 3. Now everything is a prime number. So the prime factors of 24 are 2 times 2 times 2 times 3. To find the GCF, we find the common values and multiply them. Here 2 is common to both. And then 3 is also common to both. Our greatest common factor is therefore 2 times 3. This will give us 6 as our GCF. Method 3. This is my favorite method. Here, we are just applying division. So for our question, we will take the 18 and 24 and find a number that can divide both. 2 and 3 can divide, so you can choose any. I'll choose 2. 18 divided by 2 is 9. And 24 divided by 2 is 12. Next, you'll pick another number that can divide both 9 and 12. 3 can divide both. 9 divided by 3 is 3. 12 divided by 3 is 4. There's no number that can divide 3 and 4. So we will multiply the numbers that we got, thus 2 times 3 to get 6. So 6 is the GCF of 18 and 24. It's important that you know your multiplication table. It will help a lot. Once you're very good with your multiplication table, You won't even need any of these three methods. You'll be able to straight up tell that 6 is the highest number that can divide both 18 and 24. Question 21. What is the least common multiple, LCM, of 4 and 6? There are three methods to solve this also. Method 1. We will find the multiples of 4. Multiples of 4 is basically the multiplication table of 4, so we have 4, 8, 12, 16, 20, 24, 28, and so on. Then we find the multiples of 6. Again, this is simply the multiplication table of 6. So we have 6, 12, 18, 24, 30, and so on. The LCM is simply the smallest number that is common to them. Here, we see that 12 is the smallest number that is common to both 4 and 6. So the LCM is 12. Method 2. Here, we will use factorization method. The method is like method 2 for finding GCF. We will find the prime factors of 4. 4 can be expanded as 2 times 2. Since all factors are prime now, there's nothing to do. So the prime factors of 4 is 2 times 2. Next, we work on the 6. 6 can be expanded as 2 times 3. Nothing further can be done here. The prime factors of 6 is 2 times 3. We will find the common prime factors like we did for finding GCF. 2 is common to both of them. If we were finding the GCF, we will be done here. But to find the LCM, we have to also multiply this by what is left. So for the 4, we have 2 left. And for the 6, we have 3 left. So the LCM is 2 times 2 times 3, which is 12. Method 3. This method is also just like method 3 for finding the GCF. We are using division. We have our 4 and 6. You'll find a number that can divide both 4 and 6 without a remainder. I'll use 2. 4 divided by 2 is 2. And 6 divided by 2 is 3. Nothing can be divided further. When we did the GCF in the previous question, we cared only about the numbers here. For LCM, we will multiply the 2 and the numbers at the bottom. So we have 2 times 2 times 3, which is 12. The LCM is therefore 12. We will end this video here. Please master this, because you'll need it to solve fraction questions. Question 22. Compare 2 over 5 and 7 over 8. Here, we are supposed to say if it's less than, greater than, or equal to. When you are comparing just two fractions, you can just cross-multiply. So here we have 2 times 8, which is 16. Then we have 7 times 5, which is 35. Since 16 is less than 35, we can say that 2 over 5 is less than 7 over 8. Please avoid the common mistake of putting the values on the wrong side. The position of the 16 and 35 is important. If you had interchanged them, you'll say 2 over 5 is greater than 7 over 8, which will be wrong. Just a reminder. Although we are using questions and answers style for our videos, our primary focus is to teach you mathematical concepts and methods that are needed to pass the GED Math and also help build the foundation for all future math topics. Please don't only concentrate on getting the answers. Question 23. Arrange 1 over 2, 3 over 4, 1 over 5, and 1 over 4 in ascending order. This question can be solved by converting the fractions to decimals and comparing the resulting decimals. Since we are yet to look at decimals, we won't look at that method here. We are going to solve it using the LCM. We already know how to find the LCM. You can watch our previous video if you need a refresher. The idea for solving this is that if we can make the denominators of all the fractions the same, then we can simply compare the numerators. Also, remember that when we have a fraction, we can multiply the numerator and denominator by the same number and the fraction will not change. Example, for 2 over 7, we can multiply the 2 by 5. Provided we also multiply the 7 by 5, the fraction remains unchanged. We will learn more on that when we look at ratio and proportion. For now, let's keep this idea as we look at our question. We will be finding the LCM of the denominators. This is also referred to as finding the least common denominator, or LCD. So we are finding the LCM of 2, 4, 5, and 4. You can use any of the three methods in the previous video. I'll use the division method, thus method 3 from the previous video. Please, there's no need to write a number multiple times. So here we wrote the 4 just once, although there are two 4s. So I start with 2. 2 can divide 2 to get 1. 2 can divide 4 to get 2. The 5 cannot be divided, so I'll leave it. If a number repeats itself, like the 4, there's no need to write it multiple times. Nothing can divide at least two of the numbers, so we can now just multiply the numbers. 2 times 1 times 2 times 5. This will give us 20 as the LCM. Finding the LCM of denominators, or what's simply known as the LCD, is the hard part. For the first fraction, we ask 2 times what number will give the LCD, 20, it's 2 times 10. We multiply the numerator and denominator by 10 to get 10 over 20. We do the same for the 3 over 4. 4 times what number will give us the LCD, 20. It's 4 times 5. We will multiply the numerator and denominator by the 5 to get 15 over 20. We now work on the 1 over 5. 5 times 4 will give 20. So we will multiply the numerator and denominator by the 4 to get 4 over 20. Finally, we look at the 1 over 4. 4 times 5 will give us 20. So we will multiply the numerator and denominator by 5 to get 5 over 20. Since we have made the denominators the same, we can simply compare the numerators. For teaching purposes, we showed what happens with the denominator. In the GED, since we know that the denominators are going to be the same, we could have just concentrated on the numerators. So no need to multiply the denominators. So 4 is the smallest numerator. So we have 1 over 5 as the smallest of the fractions. Then we have 5. This means 1 over 4 is the next. Then we have 10. So 1 over 2 is the next. Then finally we have 15. Meaning 3 over 4 is the largest. Question 24. Add 1 over 7 plus 3 over 7 plus 2 over 7. This is really the easiest form of fraction questions. Here, all the fractions have the same denominator, 7. You will put that as the denominator of the answer. Since they have a common denominator, you'll just add the numerators. So we have 1 plus 3 plus 2. This is 6. So our final answer is 6 over 7. Pretty straightforward. Let's take our next question. Question 25. Add 2 over 3 plus 1 over 5. There are two ways you can solve this. Method 1 is the cross multiplication method. The first step is to multiply the denominators. We have 3 times 5. This will give us 15 as our denominator. Then we will cross multiply. 2 times 5 is 10. Plus 1 times 3 is 3. 10 plus 3 is 13. So we have 13 over 15 as our final answer. The work here is just being able to remember the steps. This method usually works for small numbers and also when you're dealing with two fractions. As you increase the numbers or add more fractions, this method is not very effective. Method 2 is the LCM method. The format is exactly like what we looked at in question 23 from the previous video. Here, we'll find the LCM of the denominators, 3 and 5. We know that the LCM of the denominators is LCD. This is 15. We looked at three ways of finding the LCM in question 21. You can refer to it if you need a refresh on finding the LCM. After finding the LCD, we'll take the first fraction and ask 3 times what number will give the LCD, 15. This number is 5, so we will multiply this 2 over 3 by 5 to get 10 over 15. Next, we will ask 5 times what number will give us the LCD, 15. The number is 3. We'll multiply the 1 over 5 by 3 to get 3 over 15. Now we can see that the fractions have common denominators. We said we can simply add the numerator in this case. 10 plus 3. This will give us 13 over the 15. Please, the two methods we used here are nothing new. They are exactly the same process we used to compare fractions in the previous video. Let's look at our next question. Question 26. Multiply the fractions 3 over 7 and 2 over 5. Multiplication is the simplest operation in fractions. All you have to do is multiply the numerators together and then multiply the denominators. Here, we will multiply 3 times 2 and then multiply 7 times 5. This will give us 6 over 35 as our answer. The only difficulty here is your ability to multiply. Question 27. Divide 2 over 7 by 1 over 3. The work here is to convert the division question into multiplication and solve it exactly like we did in question 26. You'll maintain the first fraction, 2 over 7. Then you'll change the division into multiplication. Then finally, you'll flip the second fraction. So instead of having 1 over 3, we'll have 3 over 1. The rest is just multiplication like in the previous question. We will multiply the numerators. 2 times 3 to get 6. Then we will multiply the denominators. 7 times 1 to get 7. So our final answer is 6 over 7. Question 28. Change the mixed number, 2 whole number, 3 over 4 to improper fraction. To change from mixed number to improper fraction, you'll simply multiply the whole number by the denominator. Then you'll add the numerator. So here, we will have 4 times 2 to get 8. Then we'll add the 3 to the 8 to get 11. This will be over the original denominator, which is 4. So our answer is 11 over 4. The difficulty here is remembering the steps. Most students are able to follow along, but they forget how to do it during the test. Please try this. 5 whole number, 2 over 7. Pause the video and try it. We will have 7 times 5, which is 35. Then we will add the 2 to it. This will give us 37 over 7 as our answer. Question 29. Change the improper fraction 23 over 5 to mixed number. To convert from improper fraction to a mixed number, all you need to know is division. Let's set up a long division. 5 times what number will give you a number close to 23, but not more than 23. 5 times 4 will give 20. We put the 4 here and we put the 20 here. Now we subtract 23 minus 20 to get 3 as our remainder. The value here will be our whole number. So our whole number is 4. Then the remainder will be our numerator. So this is 3 over our original denominator, which is 5. So we have 4 whole number, 3 over 5 as our answer. We will add a video on long division for those who need to revise. Once you know long division, this will be easy. Question 30. Subtract 12 over 7 minus 5 over 3. Solving questions on improper fractions is exactly the same as solving question on proper fractions. Here, we will use the cross multiplication method. We multiply the denominators. 7 times 3 to get 21. Then we cross multiply. 12 times 3 to get 36. Minus 5 times 7 to get 35. We subtract 36 minus 35 to get 1 over 21 as our answer. This video is just the beginning. We want to give you more. Get the Ultimate GED Math course at ultimateged.com and pass with ease. We cover everything you need to pass. Please don't fail. We can help you pass. Get the course, pass the GED Math, and say goodbye to it forever.